Thank you for the invitation. I just wanted to give you a bit of a background into Cathelco and Evac Group. So I'm Alistair Murray. I'm the Business Development Manager for Cathelco and a company called HEM, which are part of the Evac Group. Cathelco is the kind of marine growth and corrosion specialist, and the HEM is a company that does reverse osmosis water desalination systems for vessels, yachts, and the like. Cathelco itself, the factory is based in the UK, but Evac Group is headquartered in Finland. That said, they have a US entity, Evac Inc., which is based in Cherry Valley, Illinois, just not too far west of Chicago, about an hour's drive. And so for that reason, we've got military expertise and compliance. And so we are already, as a group of companies, including Cathelco, we already service certain parts of the US Navy and the Coast Guard, etc., for their vessels, and for new build through the shipyards, Eastern Shipping Group and all the likes. So we do have an established point of contact here in the USA, and we are able to deal with the US Navy. And in fact, the guys up in Cherry Valley are currently working on some kind of controller system that we know nothing about. We're just supplying the parts, and the ITAR team or whatever in Cherry Valley are getting on with it. So that's just a little bit of a background. Cathelco was founded in the 1960s, again as a corrosion specialist company, mainly just started by building sacrificial anodes, and then started looking at impressed current technology, etc. And so we've got a very well established line of impressed current cathodic protection systems for vessels to stop corrosion on hulls, and marine growth prevention systems, mainly for internal pipework, at the moment using a copper solution that's pushed into the water that prevents the marine growth. But we're here today to talk about a brand new technology called the Dragon. A bit of a play on words, which is an ultrasonic means of protecting from biofouling. So right at the beginning, I want to say we don't remove marine growth. We don't even kill marine growth. We just prevent it from forming on the hulls with this new ultrasonic protection. So you need to start with a clean hull. So either it's a new build vessel, or it's just been cleaned by an ROV and diver system, or else it's just come out of a dry dock. For the moment, it's working along with anti-fouling and corrosion prevention paints. And for the future, we would see that most clients would continue to put some sort of protective paint on their vessels anyway, from a corrosion standpoint, if not from a fouling protection. But certainly we're looking to be the kind of replacement for that in the long run. So this is part of the problem, and it's a problem coming out of the commercial world, but obviously the military is also getting on side. Here in the USA, we've got the Federal Sustainability Plan, and that's been addressed within the US Navy and their environmental readiness program, etc. And it all stems from the IMO climate action program, looking to be net zero by 2050 and a reduction of greenhouse gases by 40% by 2030. And so we looked at this as a company along with a partner, and this was the area we were looking at, that up to 25% of the greenhouse gases emitted by vessels are caused by poor biofouling management. So your increase in biofouling means an increase in drag on the hull, which means an increased use of fuel, and therefore an increase in pollutants coming out of the engines. And just an interesting point there, a fouling slime layer can trigger up to 25% increase in greenhouse gases. So what we're trying to do is stop even the slime layer, the kind of green that you'll see if you go down to the harbour and look on the walls, you'll see a green kind of slime growing before it even becomes full on marine growth. And so we're kind of reducing or removing the chances of this slime growing on the surface of the hull. The other side benefit of this, of course, is prevention of invasive aquatic species and the transfer of them from country to country. And certainly our clients in the commercial cruise line world are finding problems with that, not being allowed to go into the likes of Australia or New Zealand because they've got biofouling on their hulls, and so they have to pay a huge amount of money to get that removed. So that's the kind of problem we're looking at. Around 90% of the world trade is going by ship these days, thanks to us getting busy on Amazon and Timo, etc., etc. So that's the kind of background to it. And just jump in with any questions as they come. The IMO has made it mandatory now for commercial ships of over 5,000 gross tonnage, and by commercial ships, that's also support vessels for the military as well. Anything over 5,000, it's mandatory, and 400 above 400 gross tons, they are still required to calculate their energy efficiency indexes. And again,
Alistair,
yes,
it's Eugene. There is a question.
Okay.
So, Willis, do you want to ask your question? You're muted. Willis, we're not hearing you. You want to put it? There you go.
Maybe send out the message.
Can you hear me now?
Yes,
Yes,
we
Can
can.
you hear me now? Great. Hey, so my question is the ablative paint still being used to handle biofouling, or is that no longer being used?
So we're right at the beginning of launching this product. So at the moment, we're telling our clients to carry on with whatever paints they're using. But if, we're going to be monitoring this to see if you could completely remove the paints. But a lot of people are using a mixed paint, which does some biofouling handling and stops corrosion as well. So we wouldn't see any reason why you wouldn't want to continue painting your vessels. But at the very worst, we're going to extend the life of that paint by not allowing any additional fouling on there. And B, you'll probably be able to use a lesser strain of paint, which is less damaging to the environment, because we will be providing the biofoul element of it. So I think in the future, the people will still be using paints or some sort of covering of the hull, but there will be much less biofoul centric and more just protection against corrosion, etc.
Okay, thank you.
But we'll continue to monitor feedback from clients and see how that goes. So our system that I'm going to show you shortly is a patented system. We've got 2 patents on it, and the patent's not for ultrasonic use for biofouling. That's well known, but we've got 2 new ways of approaching it that are unique and which have given us the patents. But what we're going to do is, as we said, reduce hull fouling, reduce the drag, reduce fuel consumption and emissions, and the transfer of invasive species. We've got a non-toxic solution. Again, the paints that we discussed earlier are to a degree toxic as they rub off into the sea, and the fuel hull cleaning and downtime is going to be much reduced. A lot less cost in dry docks, etc. And in the area in orange, this is the IMO's figures, not our figures, and we just print them up there. And it very much all depends on every vessel, how you're using it and how hard you use it. But there are savings of up to $9 million of fuel over 5 years that can be made in certain cases. So we're talking about a lot of money. But also your environmental targets will be met. And of course, as I say, reduced costs and therefore budget targets being met. I won't spend too long on the kind of science of this, but really what happens is, as soon as you put a vessel into the water, bacteria are attracted to the surface. Those bacteria turn into microfouling. These bacteria are called macrofouling. They turn into microfouling. These microfouling algae cause that kind of slime, and that becomes a buffet for mussels, barnacles, and all other sorts of larvae to attach to it. So whereas most of the solutions for biofouling concentrate up on this end, removing the micro and the macrofouling organisms, we're looking at this area here where the bacteria which attract these organisms is prevented from attaching to the hull in the very first place. So that's the kind of biofouling sequence that we're looking at. So Cathelco, as I said, have already got anti-fouling solutions. We already have what we call the MGPS, a marine growth prevention system for inside sea chest, internal pipework, box coolers, and lift pumps on oil rigs, etc. And the way we handle that is by using copper anodes and an electrical charge, which then put ions of copper into the water, which kill off any biofouling that's going to settle on the inside of those pipeworks. The plan is for the ultrasonic system will eventually have a solution for the internal pipework, but for this year and next year we're concentrating on the hull only. There are other areas of a vessel, the propeller, thruster tunnels, etc., that we still are currently addressing with the R&D team, because they're much more complex areas with different types of materials, metals, and all sorts of things that make it a little bit more difficult. But for the moment, we can concentrate on the huge area, the hull, and the way we see it is if we can prevent 70% of the fouling of that $19 million 5-year cost, then, or $9 million 5-year cost, then 70% of that big number is still a big number. But the plan is eventually that we will have a complete vessel solution using ultrasonics that will include the internals. But just to be clear, for the near future, the next couple of years at least, we will carry on offering our marine growth prevention system for the sea chests and pipework, as we see that as still being a better solution at the moment.
All right, there's another question. Tom, do you want to go ahead and ask your question?
Yeah, this sounds incredible, and I just, when I get these briefs, a lot of times I say, well, then what's the downside? What is the downside? Why has the commercial world, if this was in their economic interest, why have they not wrapped their arms around this? Because it sounds like it's going to save them money, it's going to save the environment, it's going to, what is it because of the maturity? It's not proven yet. Is it costly? That in fact it may not be in the economic interest of the commercial world to do this.
So all of the above, really. The maturity is the main thing. We haven't actually commercially launched this yet. That's going to be done in the next 2 weeks, believe it or not. And so we've just been working very behind the scenes with a couple of key clients to prove the technology. So that's the reason. There are other ultrasonic systems out there in the world at the moment, and they are being fitted on some vessels. But our new patented technology is taking it to the next level, we believe. And so, so that the commercial world is just about to kind of wake up to this, I guess, when we do the launch in a couple of weeks' time, the full commercial launch. So yeah, it's kind of something waiting to happen. On the costs, I'll come on to the costs, but there are certain smaller vessels where it won't make sense, but certainly the costs involved in this will see savings, even on a vessel that doesn't do a lot of distance. Within a couple of years, and for some clients, it could be within months. But I can talk a little bit about the pricing as we go through the presentation.
Thank you.
You're welcome. So this started from a project, and this shows how long ago this started. 2012, a university in the UK, Brunel University, did an experiment on using ultrasonics. They got a lot of European Union money backing in the days when the UK was in the EU, and they also got some big names to kind of throw some money in the pot, including Lloyd's Register. Those kind of poor photographs here show, a test plate after 35 days. So this was the very original trials, and Lloyd's Register said to Brunel University, you should talk to Cathelco, because we work with Cathelco and see them as a leader in these anti-fouling and anti-corrosion technologies. And so that's how we got together. We've since onboarded a couple of the PhDs that were involved in this into the kind of team as consultants, and they've helped us build up the technology and build up the patent. So I guess, what is ultrasonic anti-fouling technology? What we're going to use, and what our competitors currently use, is a single transducer inside the hull that pushes ultrasound, high frequency sound, out through the hull. Not to be confused with cavitation. Cavitation is another form of ultrasound where you put immense amounts of ultrasound through the wall and cause cavitation, which causes the water to boil pretty much, causes a lot of vibration, a lot of extreme heat, and that of course kills anything that could be on the hull. But of course it depends on the material that the hull is made of, and so cavitation is a pretty extreme way of doing it. And so what we're using here is a lesser type of ultrasound beyond the limits of hearing, where the acoustic is sent from a transducer on the inside of the hull through to the outside. And this is how our competitors do it. They have a single transducer. They've each got about a 5 meter radius of protection, and that kind of very minute vibration prevents the bacteria from forming on the hull and forming that layer of slime or biofilm. What differentiates the Cathelco Dragon system is we're using two different technologies together to get the patent. One is guided wave principle, you may have heard of, and guided wave principle is a means of it's used a lot in the NDT world for long distance pipelines. It's even used on rail tracks on land, and using two transducers close together a certain distance apart, and then you're able to send the acoustic waves, propagate them through the hull or the rail or the pipeline, and then the majority of the waves bounce between the two inner and outer sides of the walls of the hull or wherever they're in. I seem to have lost my presentation again.
All right.
I've lost my presentation again, Eugene.
All right, can you try? Is it sharing, or if the window closes, then you'll lose your presentation? So
I'm just seeing all the names of all the people that are sitting in on the.
That's what I'm seeing too. So you want me to bring your presentation up?
Yeah, please. I apologize for this. I don't know what's happening.
All right, let me get to. I don't know if I have a copy. Okay, here it is. Give me just 1 second. Thank you, everyone, for your patience.
Yeah, thank you. I don't know if it's something that I did, but.
All right, can everybody see that? Oh, now yours is back up.
Yeah, we can see it.
I think that's yours that's up, Alistair.
Okay. For some reason, I can't see it. I must have touched one of the buttons along the top and have.
We're seeing slide 17 of 32.
Okay, let me have a look.
All right, well, yeah.
Yeah, because I don't know how to move them on from here. So I'll stop sharing and you put yours up. Yep,
that sounds good.
Thank you. Sorry, everyone.
All right, can everybody see that? You should be seeing slide 17.
Yeah, no. Think we need to be back about 11.
Oh, okay.
Please.
I can see it.
Okay, there's 11.
Okay.
Yep, we're good.
All
Good,
right.
thanks. So this is the guided wave principle, pushing more of the sound out to the sides rather than straight out through the hull, propagating it along the walls of the hull. And so you'll see that gives us a 25 meter radius instead of the 5 meter radius of a single transducer. And also we're not losing as much energy into the water either, and more of it staying within the walls of the hull itself. So that's two transducers of the same frequency, a certain distance apart, and that provides us with the capability to propagate through guided wave principle. So the second part of the patent's on the next slide, which is called the heterodyning principle. And heterodyning says that if you take two transducers of a different frequency and run them a certain distance apart, not only will you get the two frequencies that you're running from the transducers, but you will get the sum of those two frequencies, and you'll also get the difference of those two frequencies. So, for example, if you were to take a 200 kilohertz and a 300 kilohertz transducer and run them together a certain distance apart, you would also get 100 kilohertz and 500 kilohertz being formed as well. And the good thing about that is you've now got a much larger range of frequency, which is able to deflect a larger range of bacteria, because the findings of the university were that different bacteria in different situations, maybe different temperatures, different water qualities, react to a slightly different frequency. And so we put the heterodyning principle to give that full range of frequencies, along with the guided wave, which then pushes it out much further and gives us a much broader area per group of transducers than using the traditional way of a single transducer. Yes, you do have 4 transducers instead of 1, but as you'll see in a minute, it makes a huge difference. So if we can just go to the next slide. Thanks. So this is a kind of installation. There's the 2 transducers of different frequencies. We just call them red and green. It's kind of our secret sauce, so we don't talk about it too much. In fact, I'll stick on my camera just now. I've got one in my hand so that you can see the actual size of them. And so there is a plate which is attached on the inside of the hull with an epoxy resin, and then the transducer is screwed onto the top of that, and it's got a lead for power and data to go back and forth. So two each, because you need 2 of each to get the waveguide up of the same frequency, and the 2 different for the heterodyning. And so you end up with what we call a quad going to a panel, or a group of quads going to a panel, and then going to the power supply. For those of you who are interested in power, they run on at the moment, normally it's kind of a 220 to 260 volt system, but other voltages could be catered for. A lot of ships have 440 volts, and we could certainly deal with that with a step down transformer. But more importantly is the power draw. And so one of these quads is using about 120 watts, and that a set of quads probably about 480 watts. So it's very, very little drain on power consumption. And I think that's about it. As you saw if you saw my video, they're about half the size of a coffee mug or a beer can or whatever, and they're very easily to fit. There's no hot works, there's no penetrators needed. They can just be epoxied on the inside of the hull. One question that comes up a lot, and again, because we're at the early stages of developing this, they need to be in a dry area at the moment. We don't have an IP rating on these, although they are, kind of waterproof. They're water resistant, I would say. But the next stage next year is to produce an IP variant of these, so that we can put them direct into things like water tanks, etc., ballast tanks. And also, there's many vessels out there that there is no such thing as a dry area inside, and so we're aware of that. But for the moment, we're looking at dry area placement. Thanks. I think we'll go to the next slide, Eugene.
All right.
So this is what they would look like for a 100 to 150 meter vessel. 6 quad configurations going to 2 panels, and a fairly simple setup. I already said there's no hull penetrations, no hot works, no surface preparation. It can be done in the dry dock, or if time's limited at the dry dock and expenses is accrued, then you could bring it out of the dry dock into the main dock, float it, and then quickly attach these so that you're ready to go, or as a new build. That's for a 150-meter vessel. So if somebody asked about the pricing, is very dependent on how we install it all. But a very, very rough kind of guide to this is about $1,000 per meter. So a 100-meter vessel, a 300-foot vessel, would probably be about $100,000 to install that. And as I say, you could see savings on that in less than a year, or if you're not using it very much, maybe 2 to 3 years on your hull, on your fuel costs. But then you're not going to have the cleaning costs. I'm told that a tourist cruise liner will pay up to about $200,000 per year just on active hull cleaning using ROVs and divers, etc. So there's a lot of savings to be made, and yet, as per the earlier question, we think the commercial world's going to embrace this very quickly, very soon, once we've proved it to everyone. Okay, we'll take the next slide. This will show you what it looks like with the ultrasonic solutions that are out there at the moment. With the 5-meter radius, that's what they would look like on a 250-meter vessel compared to ours. So although our transducers are in quads instead of singles, we've only got 10 transducer locations as opposed to 96 locations. So we've got a much better chance of finding the right places to fit these. And we're only using 40 transducers as opposed to 96, even although we're grouping them in groups of 4. So again, a lot of savings to be had. Okay, I think move on to the next, the kind of reference cases. The next slide will show the next reference case. This was the very early days. This was 2 narrow boats in the UK. These are canal vessels that used to be used for transport. They're now pretty much used for vacations and tourists and the like. And they're in freshwater canals, so there's not a huge amount of marine growth. But this is way back in kind of 2013. It still showed that the hull that had the transducer on it, the early type of transducer, was kept clean, whereas the test vessel had a fouled hull. So that was a very early test. Okay, you can go to the next one. This is a good reference case. They've just been down to see it again in the last 2 weeks. It's been on there 5 years. Again, it's a very early version of the system. But as you can see, the hull's really nice and clean, even after 5 years. This was it coming into its dry dock. We also had the chance to integrate this with our ICCP systems and the RO water systems, and so it just proved that they weren't interfering with each other, because that's one of the problems or potential problems being raised by potential clients is this going to interfere with other electrical equipment I've got on board. We've run it alongside sounding sonars, forward-looking collision avoidance sonars, and there's no interference, and it comes later, but no interference with marine mammals either. So that's been a good reference case for the super yacht world, who funnily enough could care less about how much money they're going to save, but they like to have a nice, beautiful, clean looking hull, especially with the expensive lacquers they've got on their hulls, expensive paint jobs. We can go and look at the next one. This is the Bainstown connector in Vancouver. So it's a little ferry, a chain pull-driven ferry that goes between Vancouver Island and one of the smaller islands offshore. Now, the challenge they had was, over the years, they'd had to drop from something like 12 trips per day down to 10 trips per day because of the sheer weight of the marine growth on the vessel was putting a strain on the motors that drive the chain. And so they had to reduce the speed of the motors, and so they had to reduce the speed that the ferry was going back and forth, and therefore reduce the amount of times per day. So that's been on there for I think about a year now. 2 weeks or 3 weeks ago, they sent some divers down to have a look. So what they did was they did a patch test. They cleaned 2 areas of the hull, and they put the transducers on the inside of the hull where one patch was, and left the other one. And so the divers went down, and they've said there's a huge amount of marine growth on one patch, and the other patch is clean. And so this is due out of the water on the 7th of April. And so we're hoping to get some really good video and photographs of the proof that this patch with the transducer is completely clean. But I believe, I'm told from the team back in the UK, that BC ferries who run this are already asking for quotes for getting the whole system rigged out when it comes up in the dry dock. Assuming that what the divers told them is true, and that it has prevented the marine growth. So we're very confident of that.
So, Alistair.
Yeah.
So this video that we're recording today is going to go up on our YouTube channel. Would you be able to attach that video to this, or send it to me so I can upload it?
Yeah, certainly. As we get further proof of concept, I'll keep in touch with you and send you details of that. Yes. Yeah,
I think it'd be great for the audience.
Yeah, absolutely. And as the kind of business development guy, it's a tough sell at the moment, because it's all smoke and mirrors. Because we keep telling everybody's happy with it, but nobody's got any good photographs, apart from that yacht down in the south of France. And the cynic in me would say, "Oh, well, that's any old yacht, clean yacht you've just taken a picture of." So yeah, we will have some good testimonials, but yeah. We're just at pre all of that and pre-launch. But it was a good opportunity to talk to people and make them aware of the technology. And this is not a third-party verification that's been done. The IMO put us in touch with DHI in Denmark, and they're a scientific organization that do a lot of marine testing. And so again, there's not a lot of good stuff to see here, but they did fill 2 water tanks up with algae, and fitted one with the quad, and of course after 43 days there was no barnacles inside the tank with the quad running on it, and the test tank did have the started formation of barnacles. But one of the other good things that it showed was that on the other side of the tank there was no growth either, and that was the first time we proved the waveguide theory was working, because obviously it's pushing it all the way around the tank. So you've almost got a vessel hull in reverse here, with the water on the inside and the transducers on the outside. On to the next one. So yeah, DHI also did the verification with the cetaceans and other marine mammals, especially higher frequency cetaceans, harbor porpoises, and they said that there was no significant impact on the sea mammals. So I think by that they're saying, yeah, the dolphins can hear it, but they're not adversely affected or running away, swimming away because it's damaging their hearing or anything. So there was no significant impact on any of the mammals. And on to the next couple of slides. So yeah, we're at the stage now where we're just about ready to do quotations. If somebody has a particular vessel they wanted to have this on, we now have a means to, if you send us the kind of GA drawings, we can put together a quote of how many transducers you would need, what the layout would look like, and what the cost would be. And as I said, the official product launch, Q1 2024, slightly late, so it's probably going to be about 3 weeks' time that we have the official launch. Again, I'll put your name on the list, Eugene, so you'll get inundated with the launch materials, and
absolutely
follow up with any other stuff. And as I say, one of the, we're talking to potential military clients here. So, one of the thoughts that was raised by myself when I joined the company recently was, I don't think the military are going to want something making ultrasonic noises on their vessels. So a couple of things to think about. One is, although this is designed to be fitted on a vessel and left on 24/7, about 99% of the attachment and growth occurs in shallow water. So once you make way out beyond the, into deeper water and start making headway across the Atlantic or whatever, then there's very little in the way out in the open sea that's attaching itself. It's nearly all in the shallower, warmer waters, and nearly always when you're, tied up alongside in the harbour. So even for things like submarines that we know have a huge problem with marine growth, the idea is you would run this system while you're in port or while you're in in harbour, to prevent all that. And then once you go operational and start diving, then you're not going to have the problem of the, especially as you're diving deep, you're not going to have the problem of attaching marine growth to it. So we still see that this could be a good solution for for the Coast Guard and many of the defense vessels out there.
Yeah, let me interrupt you here for a second. So for the people that are here and in the military or the Navy, this would be a good opportunity for a CRADA to be able to put this on a small boat and turn it on when it's in port, turn it off when it's not, and help them to identify and prove that case.
Yeah. And if there's anybody from Carderock out there that wants to, do some proof of concept with us, we'd love to talk to them as well.
Yeah, well, I used to be there, you know that. So I'll reach out to them.
Yeah, I'm in Florida, so like you, so there's some guys not too far from us down the road. So.
Well, right, Fort Lauderdale has the corrosion lab.
Yeah.
So I'll reach out to them. All right, you want to go ahead and wrap this up?
Yeah, I think just take there's only 2 slides left, and I think pretty much the sales pitch after that. Yeah, this is just the sales pitch, and then there's some references there that anybody wants to read about, where we got our data from. Like I say, we don't put our data out there much. We pretty much quote what the IMO's quoting and take it from there. But ready to go to market. We seem to have some happy early adopter customers. We've still got quite a bit of cynicism out there, quite rightly, because it's a new product, and so the good thing is we talked to one of the cruise lines, and they said, well, hey, we could just do a patch test on this and take it off on a cruise and come back. It's non-invasive. It'll either work or it won't. If it does work, then we'll be happy, and if it doesn't work, nothing got harmed, and we'll give it back to you. So but we're positive it's working because of all the other testing we've done. We've been very careful before we come to market with it, that we're sure it's gonna work. The only thing we really need, apart from the one yacht out there and the ferry, is some real long-term feedback and proof of concept.
All right, thank you very much.
Thank you.
I'm going to stop displaying because I had to open up a stop
Yeah,
sharing
apologies. I don't know what button trouble I had.
That's all right. Yeah, so I was having troubles too. I had to open up a second window in my browser so that I could see the people if anybody was raising their hand. But
right.
But anyway, so it's open for questions. I know people are chiming off. Last thing I would like to say is that Tom Russell had brought up a point as to why don't people know about this, and why isn't the commercial industry buying into this? And Alistair said it, that it's new, and you'll find that a lot of these technologies are new and unknown, and that's part of what we're trying to accomplish here. The community there's a lot of researchers, a lot of scientists. Most of the federal labs are part of this community, and they're the ones that are feeding us with these technologies and these ideas for presentation. So you will find more often than not that there's a lot of concepts and a lot of new unheard technologies that are presented on this forum. And that's one of the goals, is to educate people and to make people aware, because not everybody has the time to do the necessary research. And that's what we do with this community. We're close to 3,000. And when you look into 3,000 and their peers, we got a lot of people helping us out. So I'll wrap it up there. Thank you, Alistair. Thank you
you so
everybody for
much.
attending. And again, these should be up hopefully by February or by Friday on the on YouTube. And I will post the presentations themselves on the excuse me, there I had something else going on, but I'll post them on the document repository, which is accessible through the website. So if anybody has any questions for me, for Alistair, please chime in. Otherwise, I'm going to start checking people out of the meeting.
Stunned silence.
What's that?
Stunned silence.
Yeah. It's been a long,
Yeah.
I mean, it's 2 hours and 15 minutes, 2.5 hours for those that are on from the beginning. So
Yeah. Yeah.
that's asking a lot of people, but most people chime in and out.
Yeah, I appreciate it. Okay.
All right. I will be talking with you later.
Thank you.